Welcome to the video on section 7.2, which is perpendicular bisectors of a triangle. So I'm going to start off by explaining this chapter by going over problem 7.5. Sorry about that. 7.5. And so it says, let K and L be the perpendicular bisectors of AB and AC of triangle ABC shown. So I've drawn it already as the figure shows. So K is the perpendicular bisector of AB, and L is the perpendicular bisector of AC. Now it says in A, from what 2 points must every point on K be equidistant? And since we know that the perpendicular bisector of a line is all the points that are equidistant from each point, so K is all the points of A and B, and all the points that must be equidistant from line L is the line A and points A and C are all the points that are equidistant from these points is line L. Now it says in C, let O be the intersection of K and L. Why must O be on the perpendicular bisector of BC? Why must it be on the perpendicular bisector of BC? So we have that. Okay, so let's look at it like this. So we have that since this is the perpendicular bisector of this, that this is equal to this because it is all points that are equidistant. So this point right here, O, is equidistant from A and B. So this is equal to that because it's equidistant. And now since O is also on the line L, and it's on the perpendicular bisector, since L is the perpendicular bisector, this line AO and OC have to be equal as well because they're equidistant. So it tells us that AO is equal to BO, which is equal to CO. And what this tells us is, okay, so since since all of these are equal, if you were to draw a line through O towards BC, it would go through like that. We already have that these two triangles are equal right here. These two sides are equal right here. And since this side's equal to itself, you have that these two triangles are congruent by hypotenuse leg congruency, since this would be 90 degrees because it would bisect it. And so it's 90 degrees there. You got it congruent. And so since these two triangles are congruent, we have that this side's equal to this side's equal to this side, this side's equal to this side, so this is equal to this. So O, since we make that line and it works, O has to be on the perpendicular bisector of BC, and that's how we find that out. Now next it asks us to draw a circle. So if we draw a circle with the center of O and the radius of OA, will the circle go through BC as well? Why or why not? So let's just draw a circle right here. So we draw this circle. Now, I have drawn it so it puts points B and C in there already, but let's think about this. So if AO is the radius, if AO is equal to BO and CO, then these are also equal to the radius. So in the radius, all points that are just, so this is also the radius right here. This is also the radius right here. So basically all a circle is the length of the radius and all the points around the side. So it would include B and C because they're as far away from O, which is the center, as the radius, since they're equal to the radius. So that's how we can find out that they are part of it. Now what's so important about this is the perpendicular bisectors of the sides of a triangle are concurrent at a point called the circumcenter, which is O, which is right here. And concurrent means that they all meet at a single point. So the perpendicular bisectors of AB, BC, and AC all meet at point O, which is the circumcenter, which is the center of this circle too. And the center that is centered around the circumcenter passes through all three vertices of the triangle that makes that circumcenter. And it is called this circle is called the circumcircle. And it's because it's circumscribed around the triangle, which means it goes through all three of the vertices of the triangle. And the radius of this circle, which is AO, BO, or CO, or any other, like, it's basically the radius of the circle with O being the center, is called the Circum Radius. And that's usually called R. So the Circum Radius is usually R. And so this is why it's important in this problem, because it brings about the circumcircle and the circumcenter. Now, I've skipped over explaining problem 7.6, but what's important to know about it is if you have a right triangle here, the circumcenter of that right triangle is going to be the midpoint of the hypotenuse. So if we look at it, if you were to draw all the perpendicular bisectors like that, they would all meet at this point O, which is the midpoint of AC. And since this is the circumcircle, the distance from O to B, O to A, and O to C, they're all going to be equal like this. Now, it's important to know that for the circumcircle of a right triangle, the midpoint is the midpoint of the hypotenuse is the circumcircle for all right triangles. And the circumradius is going to be, if you were to draw a circle, the circumradius is going to be the length of OB, OA, and OC. So that's important to know for a right triangle, that the circumcenter of a right triangle is the midpoint of the hypotenuse, and the circumradius is going to be equal to 1/2 the hypotenuse, which is this distance right here, this distance right there, and this distance right there. And that's what you learned from 7.6. Now, the last important thing in this section, which is very interesting, is from problem 7.7, and instead of going through all of it, I'll just explain the principle. So if we have here two dots, if you draw a line between those two dots, that's how you make a line segment, and that's how you determine a line. If you have two dots, 2 points, and you draw a line between them, that's how you make a line. So with a circle, let's say you have 3 points, and with these 3 points, you can make a circle. Now, if you have any non-collinear 3 points, and what non-collinear means is that it's impossible to draw a single line through all 3 of these points. So no matter what I do, I can't draw a line like this, I can't draw a line like that. No matter what line I draw, it will never go through all 3 of these points, because this right here, if I went like that, that's not a line. And so the way to do it is, if you have 3 non-collinear points like these 3 right here, there is always one circle that will go through all 3 non-collinear points. And it passes through all 3, no matter what you do. So we have 3 points, and you can draw a circle like this, and it passes through all 3 points. So if you have 3 non-collinear points, you can draw a circle through them. And so that's something interesting from section 7.2. And now I'm going to move on to 7.3 in the next video, which is going to be on angle bisectors of a triangle.